Everybody, we'll get started here in just about 15 minutes, so just let you know we're here. So everybody, welcome to the webinar today on extending DevOps to the database with continuous integration. And hopefully you're excited about this topic and you want to learn something. I think we've got a lot of great tools from Redgate, and we want to obviously show those to you, but we've got some great ideas, I think, that are valuable to you no matter how you might choose to do database development. I think it's very informative, and I really like this story that we try to present to you every month in slightly different ways and how DevOps for the database works. So let me start with, I'm Steve Jones. I work for Redgate Software as an evangelist. I also run SQL Server Central. I founded that site a long time ago, and it's been my full-time job. So all my contact information is up there, but I'm essentially a long-time DBA and developer. That's been most of my career for nearly 30 years now, and I've worked in a variety of different companies in different industries, big and small companies, that kind of thing. And so I've had all that experience, which got me this great job, but has allowed me to, spend my time working with different clients and customers, understanding their needs, giving them ideas that may help them showcase that knowledge both in person at customers, clients, and at events, as well as in the written sense at SQL Server Central and other publications. And with me today, I have Arneh Eskandari. Arneh, I'll let you introduce yourself.
Sounds good. Thanks, Steve. Before I actually do that, I'd like to give you a shout out as Steve is coming up to his 10 years here at Redgate. So as you all know, he's played a significant role, not just on the SQL Server side of things, but with product roadmap, strategy, and his feedback into our product team has definitely helped us move in the right direction. And I feel very humbled to have had the opportunity to work with him.
Thank you, Arneh.
Yeah, so I'm Arneh Eskandari. I'm currently in charge of the sales engineering function here in the North America region. As part of my role, I've worked with hundreds of organizations in different industries, finance, healthcare, technology, and have helped them implement DevOps and standardize their DevOps practices across both their applications and databases. So here's my contact information. So if you have any questions after the webinar or need anything, feel free to reach out.
All right, thank you, Arneh. So today, the quick agenda. Now, the first 3 or 4 things here, I'm going to kind of talk about, or maybe all of these except the demo, but I'll try to go fairly quickly because we really want to spend time in the demo and let you see one implementation of how database DevOps works. And Arneh's got a great demo set up, and if you are interested in any of the things that we show you today from the Redgate side of things, you may work with him. He does a fantastic job as a sales engineer out there. Let me start with an introduction to Redgate. Now, as Arneh said, I'm almost been here 10 years now. I guess I have been here 10 years, but we'll celebrate it tomorrow or Thursday. But Redgate's a small software company based in Cambridge in the UK, where actually I am today. But we have offices in the US as well, and we have people working all around the world. Now, we've really primarily worked on building tools that help you work with SQL Server, both in development as well as administration. We do have some Oracle and .NET tools, but really we focus on the SQL Server market. And our goal really is to make your job easier. We try to build these ingenious, simple tools. And we've got customers all over the world. We sell to thousands of companies all over the world, both big and small, but plenty of big companies for sure. And we also give back to the community. So we definitely want you to buy our software, if it solves a problem and it's a good value for you. But we support SQL Server Central and SimpleTalk as educational sites. And so we try to give back to the community in that way, providing educational information. And then we sponsor lots of user groups, SQL Saturdays, those kinds of things as well. Certainly we have a marketing benefit, but we just strongly believe we're a part of the community, and whether you buy our software or not, we're happy to help you build better software along the way, especially with SQL Server. Now, the one thing I do want to point out in here, last year we had a lot of product releases, and we're on incredible pace this year. We only have 20 or 30 products, so we don't have that many products, but you can see we have over 1,100 releases that we did last year. That's primarily because we work in a DevOps type format. Now DevOps isn't prescriptive. It kind of is this idea, but we have groups that work in pair programming and Agile and Scrum and different methodologies. But we definitely work in the idea of DevOps that we want to release early and often, lots of small changes, get feedback from customers, and constantly iterate and evolve and be very, very responsive. And lots of companies want to do that as well. I'm sure many of you have seen that DevOps is a hot topic. It's something that many companies talk about, the media talks about. And the reason is primarily that it has a lot of advantages. And I'll talk about those in a minute. But there's a challenge with integrating your database into a DevOps process. And as much as I've studied DevOps and talked with practitioners in various companies around the world, these things cause the database often to be left out of the process. And really, it's data that's the issue, that we have to preserve data. We can't lose it. We can't compromise the integrity or change it when we're trying to deploy our software. And really, it's the state of the table that is the problem. So databases have lots of objects, right? Oracle has objects, MySQL does, SQL Server does. Views, stored procedures, functions, modules, those types of things are code, just like application code, C#, Python, Java, whatever. But the tables carry state. And so I have to evolve those tables. I can't drop them and recreate them like a C# class. If I could, life would be very easy, but I have to maintain that data, that table and that data. So it's a challenge. And what we find, even in DevOps areas, is that the database is often shunted to the side, and they haven't integrated database DevOps into their other software development. And so the database is often not only out of pace with the rest of your applications, but it becomes a bottleneck in the process. And that's a challenge to trying to move fast. And it leads certainly to developers reusing columns or trying to use different data stores or other things that often aren't the best choice architecturally for your software. We also have the issue that when this is off to the side, it doesn't have the same instrumentation, the auditing, the traceability of the application changes. And so often they're ad hoc changes, often rollbacks are kind of an issue. And because there's all this work we do, we tend to bunch up those changes because we get nervous and we get scared, and we release less frequently on the database side. Because we release less frequently, we're not practicing it, we're not following processes, there's more risk involved in what we do. Certainly, anytime you're changing data, there's inherent risk, but when we do this less often, there's more risk. Because we often do it as an ad hoc format, it's often manual, and it's a lot of time. And I think when you study almost any software development team, the time is your most valuable resource. It's not the skill of the developers or how many developers you have or anything. Time really is what's very important to you. So the more often I can release, the less hours that I can use, make a huge difference to how productive and efficient I am. Now, if I move to a database DevOps process and I incorporate the database into a DevOps flow, just like my application software, what I'm really trying to do is create a repeatable, reliable process that I can go through over and over and over again. And primarily what I'm doing here is I'm trying to eliminate some of the ad hoc manual changes that I depend on the skill of a DBA to do, because that's really not what I want to pay the DBA to, or the sysop, or even a developer to do, right? I want to pay them to solve problems and do creative things. The kind of tedious process of going through certain steps, connecting to machines, doing things that can be easily automated, I want to get rid of that. And when I do that, what I can start to do is release more often, because I have confidence that I'll get this release out the door. And I can make smaller changes because I get the flexibility to release at my pace. And then certainly, as I build a process out, I have the ability to add in automated testing, which further reduces my risk as I start to find patterns or practices or ideas that will flow smoother. I have the ability to provide testing in there, which is something that, again, in the database world is often done ad hoc, not informally. I can help the software flow through the same way that I do in C# or Java or something else. Now, Redgate, we do a lot of research on this. So not only do we building software, but we're trying to build it intelligently. We talk to lots of customers, potential customers, people in different industries and in different software development roles. we try to find out what works out well. So we've started to produce a state of database DevOps every year, and we've done this in conjunction with professionals that actually know how to do surveys in statistically significant ways. And so what we found in this year's report is that most companies, the vast majority in fact, are looking to adopt database DevOps. A lot of them are going to adopt DevOps as well, which, as I said, isn't prescriptive, so technically anybody could complain or claim that they're doing DevOps now, but certainly companies are making an active effort to become better in their software development. And then the biggest driver for moving the database into a DevOps process is that they want to have the database match the pace of application change, right? It doesn't mean that every deployment has a database change. It doesn't mean that we deploy as often as the application software, but we want to be able to match their pace in terms of delivering features and functionality to users. And certainly this is not just DBAs that are asking for this, or it's not just developers, but it's people that often work across both sides of the application, right? Both on the front end, middle tier, and the back end, because they realize that that's an integrated process that has taken place. If you want to download the full report, you can certainly do that and see what other information we've got in it. And part of the reason that we've pushed into DevOps and that we're bringing the database along is that DevOps in general has just proven that it helps companies in a variety of ways. Now, Puppet Labs always does a state of DevOps report just in general for software. Unfortunately, that often kind of ignores the database. But last year's Puppet Labs report shows the same thing I've seen for multiple years from them, that the more often that I incorporate certain practices like version control, continuous integration, automated testing, those kinds of things, the more high performing my IT organization is. And it's not that they rate the organization against each other, but the IT groups themselves, the companies themselves, are finding their IT performance internal to the company is increasing. And that as the companies become more agile, as they get more a smoother process that goes through, they're deploying code more often, but that's not really the ultimate goal. Really the big things are that their deployments less often cause issues, right? Certainly there could be logical errors in how we've implemented a feature, but the deployment themselves of getting code to customers, there's just a lower failure rate of that. So it means they don't have to roll back. And when they do have an issue, or there is an issue, whether that's infrastructure or code, they recover so much faster. And that's often due to the fact that the entire process is instrumented. They know exactly what things are changed, and so they understand what needs to be fixed. So their troubleshooting is just much faster. And maybe most importantly, upper management realizes that when we build a high-performing IT organization, both in development and in infrastructure, that I'm more profitable. I have a higher market share. I can meet the goals that the business has for our particular organization. So how does Redgate help? Right? Now, the general process that Arneh will talk about, the goals, could be done multiple ways, but certainly at Redgate, we've poured a lot of effort, a lot of brain power, research, practice, beta software into figuring out how this helps. And so we've built a lot of tools that kind of smooth this process along, and we think that the value you get out of developing database software better is more than worth the price that you pay. So if I bring you a flow here of software development from the developers on the left to production on the right, you can see that we've got various sections that we've put together and various tools from Redgate that fit into these areas, and then various software development tools from other vendors that we plug into. So we try to be very tool agnostic in terms of the entire DevOps process. So we're happy to plug into TFS or Git or Jenkins or Bamboo or Octopus or Go or anything else that you want to use. So if I walk through the flow, if you look here on the left, I have developers that have to work with version control. Now, I hope most of you actually do work with version control with your databases. If you're writing C# or Java or Python or other software, you absolutely should be using version control. But at Redgate, we've built a number of tools to make this easier. So we have Prompt, which is our world-class IntelliSense product in formatting and refactoring that allows you to write the code quicker. We have SQL Test that allows you to implement testing, and then SQL Source Control and ReadyRoll, which both allow you to store data inside a version control system. And we'll plug into Management Studio and Visual Studio and then various version control systems as well. once I've got the code there, we're trying to help ensure that you capture all the code you've written and you put it into a place. And then we move on to a continuous integration area, which is our focus today, where we want to automatically revalidate all the changes you've put in version control. So we don't want to count on your particular development database. We want to actually have an independent system that can validate all your changes. We'll plug in any continuous integration system you want to use. So it could be Visual Studio or TeamCity or Jenkins or anything else. And we do this with some of our tools that automate the process, so that is a hands-off process that enables the developer to make a change, take a break, and then we revalidate everything. We run all the tests. We do all the packaging up of all the code. And then from there, what we'll do is help you deploy this code out to other systems. So the important thing here is that I want a consistent process to deploy this out to QA or testing or staging or pre-production or production. So I practice my deployment multiple times using whatever software you want to use. And we want to ensure that you have the proper upgrade script that matches your environment. So we help you translate what you've done in development into a way to deploy that. And then certainly once you've deployed it, we provide means to monitor what's going on with SQL Monitor and DLM Dashboard and SQL Backup to ensure that your data is protected when it's in production and you're aware of what's going on. So with that, why don't we flip over and do a demo, Arnie? Let's have you take control and show us how Redgate can do this.
Thank you, Steve. So let me go ahead and share my screen here first. Make sure everyone can see my screen okay. Okay, here we go. Steve, can you confirm that you can see my screen?
I can.
All right, perfect. So our emphasis today will be on continuous integration. So for those of you who are new to our DevOps webinars, this is part of the Extending DevOps to Database series. So we ran another webinar last month, which was mainly focused on source controlling and branching and merging. So if you weren't on that one or you haven't watched that webinar, I would highly recommend you to take a look at it. You can actually visit our website and watch all of the webinars that we've done in the past by going to redgate.com, Community Hub, and then from there you can click on Events and Friends, and there is webinars right here. And the one that we did last month was this Extending DevOps to Database Branching and Merging. So if you want to kind of get a better insight into source controlling database changes, how you can do that and kind of group your features and release those out on a given timeline, you can take a look at this webinar and again, let us know if you have any questions on it. So again, today we're going to be focusing on continuous integration, but in order to do that, we obviously need to start in development and start with source control. So if you're not source controlling your database changes, then you're not even ready to take the next step on doing continuous integration and continuous delivery or any of the other principles and best practices of DevOps. The databases that we're working with today is this Jenkins Git AdventureWorks database. I have multiple copies of it representing different environments that we'll be working with today. This dev database here is the database that I'll be making changes to as part of my development process. And any changes that I make here, I'll put those into source control. So I'll be using GitHub as my source control repository, and then we'll take a look at continuous integration from there. So let's go ahead and get started. So on the source controlling side of things, some of you might already know we have a plugin to SSMS called SQL Source Control, which allows you to easily bridge the gap between your databases and an existing source control system. Again, another really important factor to take into consideration when looking for solutions on the database side of things is that it shouldn't force you to make drastic changes to the way you're currently doing things on the application code side of things. So if you're using a specific source control system, then you should be able to use that exact same source control system with the new solution. And as Steve mentioned, with your CI process, with your CD process, if you already have a build system in place, such as Jenkins, then you should be able to use that for the database and so on. So in this case, we're using this tool to kind of bridge the gap between our database and GitHub. GitHub. So any changes I make to my database, this tool will automatically detect those and allow me to check those into source control. So let's take a look at it and see how it works. As you can see currently, if I refresh my source control here, you'll see that there is currently nothing to, there shouldn't be anything to commit to source control, no new changes. And the way that this works, obviously, with Git is that you have a local repository, and you also have the remote repository, which in my case is GitHub. So I will be committing all of my changes locally first, and then when I'm ready, I will go ahead and push those out to GitHub, so that way we can then trigger a build and validate our changes, test our changes as part of our CI process, and move forward. So let's go ahead and start making a couple of changes here to our dev environment. So I'm going to start up by a simple change. So let's actually go to one of our tables here. And there is a column here, or there should be a column here that we no longer need. Suffix, no one uses it, so we've decided to get rid of it from this table. So I'm going to go ahead and do that. And I'm also going to make create a new store procedure. You notice that as a developer, I don't need to, I'm not saving any scripts or keeping track of my changes because I'm relying on this tool to do that for me. So all I need to focus on here as a developer is just to make my changes. So I'm going to go ahead and write a new query here to create a store procedure. I'll be using SQL prompt for different purposes here. For those of you who are not familiar with SQL prompt, is our greatest productivity tool that a lot of people love out there, and once you start using it, then you just get hooked and you cannot live without it. So I'll be using, for example, snippets from SQL prompt to create a new store procedure. So I'll type in CP and tab, and this gives me the template for it. I'm going to go in and give my store procedure a name. So we're going to return some data from one of our tables. Okay, and I'm going to return some data here. Now, as you notice, as I'm typing, you see some squiggly lines appearing here. This is another feature of SQL prompt, which is static code analysis. This is great because it lets me know if there's any bad practices in my code really early in the process, so I don't have to make a bad change and then later on either hear back from a DBA who's kind of in charge of our deployment, or later in the process and then try to make changes then. Obviously, one of the main concepts of DevOps is this shift left mentality, which we hear about a lot. So the idea is that instead of waiting for you to do all your reviews and tests right at the deployment point, you have to do those as early as possible. So using tools like this, it can actually help you review your changes, identify bad practices or issues with your code as early as possible as a developer before you even put those into source control. So here, if I hover over some of these squigglies, you can see here it's complaining about us not having begin and end in the body of our procedure, which is a valid statement. So I'm going to go ahead and do that. Okay, and then if I hover here, it says that we have a parameter that we are not using, so I can get rid of that. This is not parameterized. And finally, the one here which says you have an asterisk in your select list. So I need to replace that because it's bad practice. So I can either hit tab and just get the list of all columns, or I can just go ahead and pick specific columns from the table. So I'm just going to pick the name of the location, the ID, and the availability. I can also format my code using SQL prompt. So if as a team you have a preferred style of writing SQL, you can actually go ahead and adhere to that using SQL prompt. So if I go ahead and say hit Control KY, it will actually format my code nicely. So you can see now I don't have any squiggly lines. My code looks valid, so I can go ahead and apply my change. And I'm also going to make one final change to data. So the nice thing about this tool is that you can also source control data in your database. So that's mainly lookup data or configuration data that needs to stay consistent between all your environments, including production. So if I right-click on my database and go to other SQL source control tasks, you can see I have this option of linking or unlinking static data. And you can see here I've selected some tables to be source controlled in terms of data. So address type, contact type, country region. So all these static types of data, phone number type, you can source control and treat that data like code. So when it comes to doing builds and deployments, this data also gets built and this data also gets deployed alongside the schema changes that you make to your databases. So I'm going to make a quick change to one of these tables here. I'm just going to insert a new record, again using SQL prompt. Gonna make it a lot faster to do that. So let's add a new type of contact. Let's just call it DevOps demo audience. All right, so we made some changes here. Now I'm ready to commit my changes into source control. So I'm going to right-click on my database and say commit changes to source control. So here the tool should show me the list of changes that have been made that we don't have in source control yet. So here you can see there is the data change. So as you can see, we're tracking data by using insert scripts. So this is what goes into source control. And then later on, when it comes to deployments, we rely on our data compare engine and the compare engine to do the deployments. For those of you who aren't familiar with our compare tools, our compare engine is really the bread and butter to Redgate. It's the tool that the company started with 18 years ago, and we still use it in different forms and shapes under different products. And here in SQL Source Control, we use the compare engine as well to do a comparison between what we have in our development environment versus what we have in source control and be able to determine the changes that we need to put in source control. So, so you can also see we have a change here with the warning here at the top saying that some of these changes could result into data loss, which we already know because I dropped a column. In this case, it was intentional, so I'm just going to go ahead with it. And finally, the new store procedure that I added here at the bottom, we can see there is nothing in source control yet because it's a new object. Select my changes to put in source control. I'm going to write a meaningful comment here for my changes. So because it's a demo, I'll keep it short. So made some schema and data changes. And I'm going to go ahead and commit this into my repository here. By the way, if there's any questions, feel free to post those in the questions tab on the webinar panel, and we'll try to get to those at the end of the session today, and we'll try to answer as many of those questions as possible. All right, so here it's giving me another warning that we're dropping this column from this table. Are we sure we want to do it? Yes, let's go ahead and do it. All right, so we put our changes into our local repository here that is sitting on my laptop. So as you can see, it's also giving me the option to push to GitHub. Another great thing about this is that I can actually see what branch I'm on. So with Git, another benefit of using Git is that it's so easy to work with branches because it's built around the concept of branches in general. So if I go ahead and switch a branch, I can easily do that, and the branch name will be updated here at the top right corner if I do that. So if you want to learn more about that, again, go back to our webinar on branching and merging and take a look at that. So let's go ahead and push our changes into our GitHub repository. And let me just quickly show you our structure in GitHub. So here's the folder structure that we built for the database when you link your database to source control using our SQL source control tool. So you can see there's a subfolder for each type of object, including data. And what we store in these folders is the definition of the object, so the create script of every single object that you have in your database. And every time you make changes, we go ahead and update the definition of those objects or the create scripts of those objects. The nice thing about that is that you can actually keep track of changes that you make to individual objects. So if I want to, for example, see the history of changes that I've made to a given object, like if I go find one of my store procedures that I know I've made changes to, and I look at the history, I can actually see all the commits that have been made to that object, and I can do a side-by-side diff of the previous versions against the current version. I can do the exact same thing from within SQL Source Control too. I can right-click on my database and say View History, and this will show me all the commits that I've done into my repository. I can see a side-by-side comparison of what's changed from one commit to another here at the bottom. And the other great thing is that we also have SQL Compare built into this process here. So if I, for any reason, I want to roll back changes that I've made and go back to a certain commit or certain version from source control, I can just simply launch SQL compare that specific revision from source control to my current development database, and either roll everything back or even roll back a handful of changes or a subset of changes that I've made to my database. So that's how SQL Compare can be used in the context of development for individual developers. All right, so we went ahead and pushed our changes to our master branch in GitHub, which should have gone ahead and triggered a build in our CI environment. In this case, I'm using Jenkins, and let's go ahead and refresh our builds here. So here's the build that we're actually running against our database. For some reason, the build failed, so let's take a look at it and see why our build failed. Okay, so let's take a look at our build log here. So I guess while we're here, so let's talk about what we're actually doing. So the idea of continuous integration generally is to make sure that your application can be compiled successfully from scratch, right? So even if you made a change or two, you still need to recompile everything to make sure that you haven't broken anything else. So it's the same idea on the database side of things. So we're basically building the schema and the lookup data of your database from scratch on a temporary database somewhere. So here you can see it's creating all the objects against that temporary database. So the idea here is to find any invalid objects or broken dependencies or any SQL Server compilation or syntax errors. So if I just take a look at my build log here, you can see that it's complaining about an invalid column name suffix occurred when executing the following SQL, and it looks like it was this store procedure. So I actually broke a dependency when I made that change to the person table. I didn't kind of check to see what other objects were using that table. But the good thing is that the build actually caught that for me. The nice thing about this is that this actually forces you not to move away from a working copy of your database. It's very common practice for us on the database side of things to just leave our invalid objects around and make sure that as long as they're not being referenced by the application code, it's okay. Let's just leave those in the database. But one thing we don't realize is that we're just accumulating technical debt as a result of that. So the sooner you actually clean up those broken objects or those invalid objects that you no longer need, that will put your database in a better state for a continuous integration and delivery process. So this, and once you get there, then this build process will actually ensure that your database stays kind of valid and you don't end up having broken objects in your database. So let's go back and fix this, right? We cannot move further before we fix that. Now, some of you might ask, is there a way for us to identify these issues before we even put things in source control or before we even run a build? And the answer to that is yes. Again, thanks to SQL prompt, you can actually go in and find invalid objects against your database as a developer. So you don't have to wait for that feedback to come from the build. You can actually just run it manually as a developer yourself. But we all know we make mistakes, we forget. So if you do forget, then at least the build will catch those for you. So let's go ahead and make our change to that object and make it valid again. So that was the get context store procedure that it complained about. Okay, yep. So we don't need this column anymore. All right, made the change. Let's commit it again. Fix the I'm going to push this again to GitHub so that we can trigger a new build for us. And hopefully that build should go through successfully. Let's go ahead and push. Okay, great. So this is going to trigger another build and see if our build can succeed this time around. A couple of things. So earlier on, I showed you those green squiggly lines and the kind of rules that we use to check for bad practices with code and the static code analysis. There is actually a big list of rules that is already defined under SQL prompt. So under managed code analysis, you can actually see all those rules here, and you can go ahead and select and deselect the ones that you're not interested in. So this is a great tool for you to catch kind of bad practices early in the process. Some of you might be relying on DBAs, for example, to kind of do those code reviews at the point of deployment, which can be time consuming, and it's kind of too late in the process for them to get back to you and say, hey, you know, I found these mistakes in your code or these bad practices that can affect performance. So this can actually help you do those as part of your development process and make your deployments a non-event as opposed to a hands-on deck where all developers DBAs are available just in case something goes wrong or something needs to be changed. So you kind of do these early in the process as opposed to waiting till you're ready to ship your changes out to production. All right, so let's go back to our build and see. So it looks like it's running. Okay, so it's, again, validating all the objects in our database. So the second part of the build is running tests. So we're going to talk about tests a bit more here, since our main area of focus is continuous integration. So you can actually see that we actually have a failure here. So out of the 35 tests that we had, one of them failed. And if you take a look at the results here, which is stored into this location here. Oh, here. So we don't, here's our test results. So as you can see, one of the tests failed, and the test that failed is it found a store procedure without set no count on. Obviously, this can impact performance when it goes into production. So it found one store procedure, USB get locations, which is actually the store procedure that I just created. So the test failed on that store procedure. So these are basically the static code analysis tests that are built into our testing framework using a tool called SQL Test. So SQL Test is another plugin to SSMS that you can use to define these type of tests. It's very easy to get up and running with it. It's actually using two different testing frameworks. One is called SQL Cup, which is a static code analysis framework. The other one is TSQL-T, which is a unit testing framework that you can use to write tests against your stored procedures or functions or your programmable objects. So if you take a look at our database that we're working with here in our development environment, I can actually run all of those tests manually from from my laptop. So I can simply right-click on SQL Cup and say run test. So those same tests are running here locally as well as in our CI process. So as a developer, I can run this test manually if I want to, but if I forget, again, those tests are ran as part of the build process. So if I forget to run it, then the build will catch it. And you can see it's complaining about the same problem here: procedure with no set without set no count on, and this is the store procedure. So I need to fix that again before I move on. So let's go ahead and do that. So let's refresh so we can, let's see, get locations here. Let's modify it. Okay. let's format it again, make sure it looks good. All right. Let's commit again. Okay, select our change. So the only difference here is the set no count on that we added. Okay, so I guess while we're committing here, so one question that popped up, which Steve actually answered, is can your build validate across databases? The answer is yes, as long as the SQL Server that you're doing your build against already has those dependencies available. So for example, if I have a dev environment where I have 3 databases that all kind of talk to each other, if I'm building one of those databases, as long as the other 2 databases are available on that same instance where we're running the build, then yes, we should be able to do the cross-check references and make sure that, for example, if a store procedure is referencing another table from another database, make sure that those are valid too. So you can definitely do it. So let's go back in here, and this is going to trigger another build. So hopefully 3rd time's a charm. While we're waiting for the build to kick off, I'd like to quickly walk you through the steps that we're running. So we have plugins for different build and release systems, including Jenkins. So if I go to my build configuration here, and here you can see we're using some of the Redgate plugins that we offer for Jenkins. So there is a build database package step in that plugin, which basically creates the database from scratch. And if it can do that, then it packages up everything from source control that is checked out into a NuGet package. So a NuGet package is basically like a zip file, which acts as the artifact for our build. So when we build the NuGet package, then we can actually deploy from that NuGet package going into our higher environments. The next step is the test database package. So that's when we ran those static code analysis tests where it detected the issue with the set no count on. So this is the second step that we run. And for our deployment side of things, we're actually using Octopus Deploy today. So we have a third step to publish the package or the NuGet package from our build to Octopus Deploy. So we can then take that NuGet package and deploy it to our target environment. So our build in this case is broken down into 3 steps. Build the database. If you can build it, package it, run the tests that we have defined for code analysis and unit test against that package. If the test passed, then let's go ahead and publish the package and prepare it for deployments to higher environments. So let's go back to our build, and yay, we have a successful build. So what this means is that now we have a package, a NuGet package that has been created. So here you can see our NuGet package that got generated as a result of that successful build. So this is a package that we can now take and deploy to our target environments. So you can see it's nicely versioned. The default versioning of the package comes from the build number. So you can see our build number was 23 that succeeded. So our packaging is taking the same build number. This makes it easier for you to look at a package and know exactly what build from your CI environment it came from. So now our next step is to, let's say we're actually ready to push these changes out to our target environments. So I'm gonna switch to Octopus Deploy. Again, you can use any tool. You can use Jenkins for deployments. You can use Jenkins pipeline, for example, to orchestrate your deployment, or you can use TFS. Any build or CI or release system that you might already have in place and you might be already using for your application code, you can easily go ahead and integrate this process for your database into whatever you already have. So you don't need to make, again, drastic changes to the way you're doing things today. So so here's a project that we have for our deployments for the adventure works. So I'm going to create a new release. You can see here it's detected the latest NuGet package that we came from Jenkins, which is again version 23. The last one that we successfully deployed was version 20. So now we're going with version 23. and trying to deploy that to our higher environments. So we have 3 environments. We have test, staging, and production. We're going to start off by deployment to testing. I could automate this whole thing end to end, but in this case, we're doing it manually so we can actually walk through the steps that we're taking to do a deployment. So let's start off by deployments to our testing environment. Our deployment is broken down into multiple steps. Again, we do have plugins or templates for Octopus Deploy that you can just easily install and define your release process. So here you can see we're using the templates to define our deployment steps for the database, which is broken down into multiple steps. So first is creating a database release, which generates the actual update script or the Delta script that we need to run against our target environment to apply the changes. So a comparison happens at this point between the NuGet package that we've built and the target environment. And based on that comparison, it generates that update script that we'll actually get a chance to review before it goes out to production. Once that script is generated, for some of our environments like staging and production, you can see we have a manual intervention step where a DBA or a release manager or whoever the gatekeeper to those environments can review the changes, make sure that everything looks good before they go out to staging or production. Once that's approved, then we go ahead and execute that script against the target environments that we're deploying to. So let's go back to our overview here. As you can see that we're deploying release number 007. Another great thing about using a release management tool is that it nicely keeps an audit of and a history of all the deployments you've done, all the releases, what was included in each release. A lot of you might already be used to using, for example, a ticketing system to do this. So a developer submits a ticket, attach their change scripts, and then those tickets become kind of the history and the audit trail of changes that you've pushed out to environments. That's obviously very time consuming, very error prone, very manual. The developer has to worry about saving their scripts up. They can forget to save a script up and later on run into issues, or there could be ordering issues, sequential ordering issues with the script, so you have to go back and reorder them. So what we find is that with those manual processes, people have to revisit their scripts multiple times until they're production ready. So the whole purpose of this solution is to prevent that and replace those manual processes with something that is more reliable, more consistent, and more standardized. So if you take a look at our deployment that we did to our testing environment, it actually generated a set of artifacts. One of those is an HTML file, which shows us a report of changes and the update script that we need to run against our targets. The first thing you see here is a warning. This deployment is dropping a column. And obviously, this is very important, especially for someone who is reviewing deployments to production. This would be the first thing they see. So in this case, again, it was intentional. We know we're dropping a column, so we're okay with that. But on top of that, there is additional changes that we've made as well, right? So we added this new store procedure, and the good thing about this is that you're basically taking the final state of that object. So if you've modified the same object multiple times, you don't have to execute sequential scripts for that object in order to get it to the final state, right? So in this case, you can see this is the final state of our object, which has the set no count on it. If you remember when we first created this object, we didn't have that. So we had to go back and modify it, alter it, and add this line to it. So instead of doing a create and then an alter, we're just simply taking the final state and just creating that object based on its final state. We can see the changes that we've made to the person table where we dropped the column. We can also take a look at the other changes that we made where we modified the USB get context to remove the invalid column, and also the data change that we made to the contact type table where we added a new contact type for DevOps demo audience. So all of these changes look good, and let's take a look at the script, make sure that looks good too. So we're starting off by making the change to our table. So adding the column and then, dropping the column, and then altering the store procedure that we modified, creating the new store procedure that we create, and then finally inserting the new record that we added to our lookup data. So the nice thing about this is that all of your changes is nicely encapsulated into a single transaction with error checks in it. So if any of these statements run into an error, then at the end we'll roll back the whole transaction, so that way it doesn't leave your target environment in an inconsistent state. If some of your changes are successful and some of your changes have failed, then you don't need to worry about rolling back the other changes that you pushed out successfully. This will do that automatically for you. So we reviewed everything to testing, looks good, so I can go ahead and promote that to staging. So the only difference with the staging environment here is that we have that manual intervention. So once it generates the report against staging, then we can review it again, make sure all the changes are as expected, and if we're happy, then we can approve it, so that way it moves on to the actual execution step of the update script. So once this create database release step is complete, then you'll see the artifacts will pop up here under the artifacts section, and that's when we'll have to review the changes. Some release management tools have this built in, such as the latest version of TFS has the manual intervention. So if you want to do manual intervention as part of your release, you can do it with TFS, you can do it with Octopus Deploy, and a couple of other release management tools. So the report got generated here, specific to our staging environment. So I can quickly take a look at that, make sure it's basically the same stuff that we saw in testing. Yep, looks good, and the script looks good too. It's all the same changes. So I can actually go ahead and approve this now. I'm wearing my DBA hat now at this point, and proceed. So when it comes to the execution of the script, we're not actually just blindly executing the script. We're doing a couple of additional things before we can execute the script. The first thing that we're doing is that I think we can see that here in the log. So you can see we're checking to make sure the target schema is in expected state before applying the update script. What this is doing is that it's doing a comparison to the previous state of the database, because we captured that as part of the release, and we do a quick compare against that to make sure that the database is still in that state. So so we don't have a drift. If we do have a drift, then that check will fail and it will not move on to the actual execution of the update script. And then once we do the update script, then we do another check to make sure that the target is now in the post-deployment expected state. And if that is valid, then we conclude the deployment and mark it as successful. So we do all those checks as part of the execution of the script to make sure everything looks good before we execute it, and everything looks good afterwards as well. So you can see our deployment to staging was successful as well. So now I can go ahead and, assuming everything looks good in staging and we've done all of our tests, I can go ahead and promote that to production. So this is basically a typical workflow. Obviously, you don't have to follow the exact same workflow, but this is a kind of standard template or approach to just doing CI and CD. Regardless of whether you're working with the application code or database, it should be consistent across the board. But we have customers who've taken a slightly different approach, modified or tweaked this approach slightly to meet their requirements. So if you guys have specific questions again on processes or how you set this up and what good should look like, feel free to reach out to us, and we'll be more than happy to talk to you and discuss this in more details as well. So we're basically going through the same process here. We're creating the artifacts against our production. Some of our customers take whatever they script generate against staging, and they execute that same script against production. So they don't do that comparison again against production, which is totally fine. As long as you make sure that your staging always matches production when you're doing a deployment, then you're good to go. And you can actually build that process into your staging deployment to do a quick compare against production and make sure everything is identical before you deploy to staging. So that's something that can be built into this automated process again. So our final approval gate here, go to production. Again, we'll review that HTML file, make sure that there is no surprises, like it's very common, I know with when DBAs go in and make ad hoc, hot fixes or add index to production and things like that, and forget to bring those back to development. So these reports.
We never do that, Arnie. We never do that.
Yeah, right. Yeah, so it's this will allow you to also catch those surprise, and those ad hoc changes or anything that doesn't look right going into production as well, and make sure you fix those before you do it. So that basically concludes our demo for today. We still have another 5 minutes. Steve, are there any questions that you think we should visit at this point?
There are a couple. Let me flip back to the slides real quick, Arnie, and then let's go.
Yeah, definitely.
If we've got that. So let's, how do I want monitor 2? Let's go. All right. So before we get to the questions, we just want to point out some of the research we've done. We've got a database DevOps maturity assessment you can take and see how you compare against other companies. So if any of you are interested in that, it's at the /maturity-assessment link. And then the state of DevOps for 2018, Redgate's helping to sponsor that. It's being run by the DevOps Research and Assessment Group. So there's a link here, and we'll email you the slides, so you don't need to kind of copy this link for now. But it's open now for a few more weeks, so you can go ahead and participate in that if you'd like. And then feel free to contact us if you have other questions or you want to learn more from Redgate. The /solutions or /hub will help you. So, Arnie, a couple of questions I think might be interesting for you to just address and put in there. First one, somebody asked about GitLab versus GitHub versus Git. They all work fine. They all work the same as far as we're concerned, right?
Exactly, yeah. So GitLab is basically an extension to Git, which allows you to orchestrate your CI pipeline. So, which is totally fine. It does support PowerShell, and our actually core engine of the DLM automation, which is what we use for the CI and CD part of things, is based on PowerShell. So there's PowerShell command lists that you can use to achieve the same things that you saw today. So, and you can easily do that with GitLab. We have customers who use GitLab. So that's GitLab is kind of more on the orchestration side of things of CI and CD, which we totally do support.
Okay. Somebody's asking as well about jobs being included in the deployment process. So I know we don't really have time to demo it, but maybe you just address that for a second.
Yeah. So we don't actually have a method for including things at the server level, so such as jobs, or sometimes people ask about BI stuff such as SSIS packages and things like that. So our tool mainly focuses on just the database object. So anything at the server level we cannot include into this. But depending on what kind of approach you take, so for example, we have some of you might already know. I saw a question on is state-based better or migrations with Redgate, which is another one of our products. So a good thing with migrations approach is that you can just build any script into that process and say execute it, right? So if I need to update a job or modify a job in a target environment, I can just put that into a migrations kind of approach or migration scripts and execute it against the target. But with this state-based approach, our main focus is just on the database and nothing at the server level.
Right. And somebody asked about Jenkins pipelines as an alternative to Octopus Deploy. I know, I'm sure you would just say the same thing, right? We just plug into all of them. We don't really care which tools you use to do the deployment or the build.
Exactly. Yeah. As I mentioned earlier on, Jenkins pipeline is totally fine to orchestrate your build and release. Again, you can either use our plugin as you saw in this demo, or you can just use our PowerShell commandlets to orchestrate your build and release process. And that's something that we're totally happy to work with you when it comes to configuration or setting things up. So just let us know, and we'd be more than happy to help.
Okay, and then the last one, Arnie, if you can just in a minute or two summarize. Somebody asked about the difference between SQL Source Control and Redgate, which are both Redgate products. So today we showed SQL Source Control. I've answered it, but maybe you each want to give your take, since I'm sure you talk to customers about this all the time.
Definitely, yeah. So really good question. So as most of you hopefully know, there are generally two main approaches to database change management. We're not talking about DevOps, just generally when it comes to managing your changes and applying your changes to your database environments. There's two main approaches to it. One is the traditional migrations approach, where as a developer, you're saving off your change scripts and then sequentially ordering them, and then run the same scripts in the same sequential order against your target environments, right? So a Redgate product follows that approach. but it has some benefits of state-based built into it. So unlike the traditional approach where it's very static, very kind of, doesn't give you much insight into what objects have changed as a result of those migration scripts, RedRoll actually does that, but it takes the migrations first approach, meaning that when you make a change as a developer, instead of putting these create scripts as you saw today, we actually put the change script. Like if you alter an object, we put the alter script of that object in source control. And then those same scripts are then executed against your target environments. There are pros and cons to each of these approaches. So the state-based that you saw today works really well for normal table changes, store procedure changes. But if you're doing a lot of data migrations or a lot of refactoring changes where you need to treat your tables and differently and apply data changes as part of your schema changes, that's where a state-based may not be the best solution. So if you're making a lot of refactoring and migration changes like that, then we recommend the migrations approach. So that's when RedRoll comes in. But if you're just doing normal changes that state-based can handle without a problem, then state-based obviously is simpler and it's a lot easier to work with. So we recommend the state-based. So depending on your circumstances and what kind of changes you're making and what kind of development work you're doing with your databases, you can go with either of those two approaches, and we have solution to both of those as you saw today.
Right. So, Arneh, do you have a favorite approach? Do you prefer the SQL source control state approach, or do you like the migrations RedRoll approach?
So, my personal preference, again, depending on what type of project I'm working on or what kind of changes I'm making, right? If I'm making a lot of refactoring changes where I need to handle those changes kind of differently and have a lot of data scripts built into those scripts, then I definitely prefer the RedRoll approach. But if not, then I prefer the state-based because it's simple. I don't need to worry about the sequential ordering of the changes and how my changes are then ordered with the changes that come from other developers, because that's all taken care of by the compare engine. So it's easier to get up and running with state-based. But with the migrations approach, you have more flexibility as a developer to put your custom scripts in and execute those scripts against your target environments. But that requires more discipline because you're still, responsible for the ordering of changes and how those changes should be executed against the target environments.
Right. I mean, I'll say I definitely prefer the migrations approach overall, but I've been doing this a long time and I've had experience with it. And it certainly is, there's more overhead and more burden on the developer, but I think it's a superior approach overall. But, you have to do what works in your environment. As Arneh said, if you've got simpler, if you're more straightforward in your DDL changes, for most developers, I think the state-based SQL compare, SQL source control approach is much simpler. So, all right, everybody, thank you very much for attending. Arneh, thanks a lot for the demo. That was fantastic, and hopefully everybody enjoyed it. If you want more information, please feel free to contact us. You will get a link later on this week, I think, where we'll have uploaded this webinar. So if you want to rewatch it, pass it to your friends, or watch pieces you might have missed, please feel free to do that. And then if you've got any more questions, get a hold of us. So thanks, everybody. Have a great day. Arneh, have a great day, and hopefully I'll talk to you soon.
Yeah, sounds good. Thanks, everyone. Have a good day.